So, this is my presentation. I'm a software architect, and I will tell you about what we use in our project. Main language is Java. I've been working for 11 plus years with Java, 6 plus years as a team lead and architect, 5 years in DevOps. I also teach at Bauman University, and I met you at different conferences as well. Okay. First of all, we need to formulate the problem. What are we going to resolve? What is Docker Compose? Have you worked with Docker? You know what is Docker build and other stuff. Okay, that's enough for our presentation. Well, we will talk about Git modules, how to assemble it, what to do. Well, talk about what we do if we have interrelated projects, several containers linked to each other, and how this can be done at the launch phase.
Okay, thank you very much. And now we're going to discuss what to do if something goes wrong. For instance, testers find a problem, they come to ResRob, they say something is not working, they look at it and say indeed it doesn't work. Okay, something doesn't work, how to understand what doesn't work, you can go to logs, but there is a possibility to debug it both within and outside of the container. As far as the second part is concerned, we don't have enough timing for that to walk through this, but you can find it in my link. You can download the repository, and there you can see step-by-step description what can be done and how it works. Okay, let's start. Let's try to formulate the original problem. We have, as a tester, I want to get local build of the server close to dev or stage. We have a lot of parallel features and we're working with them, but at some moment in time, one test contour involves, say, 4 developers. 4 developers have rolled out their features. We can test them only sequentially. We cannot put in all 4 features and decide who is wrong there. We can do this, of course, but it would look rather like we are riding a burning train on a burning bridge. Everybody is running around and shouting. It might be useful also if we understand that the task is encapsulated within a number of services, and we don't need to take out the whole contour, but only part of it. What else can be done for the developer? For the developers, in principle, there are rumors that developers are also verifying what they have done, just for the sake of interest, to make sure that it works in the first place. Also, as long as we live in microservices, sometimes it's very hard to verify, because you have to fix many things, like you take up the database and fix it, and then many other services. It means you open up 3 IDs, and 3 IDs you need to open up something, and it takes up all your operational memory in your computer. It starts to lag and slow down, and then you decide to forget about it. Secondly, it would be good not to wait for a trillion years before it's over, because even if we have to do it at a test contour, to deploy something there takes quite a while. So you send your changes on CID until it takes it up and renders and deploys it, even without raising the contour. If you have such an opportunity, more likely than not, this would be an additional decision. It's unlikely that your major decision will be about this. If not, then you will have to wait until everything is updated at the dev, and only after that you can do something. In principle, it would be great also, when I said in the beginning, to debug whatever is going on there in the services. I, as a developer, have done something. I rolled it out. I want to check the result, but something is broken. I don't know what exactly. Seemingly, by logs, it should be working, but there are some strange exceptions. I don't know. I want to look at it. I want to debug the whole thing. I will look at remote debug also, but there is a possibility to fix some of the application in the contour and others locally. Okay, we have a docket, and within microservices, the Docker can be quite helpful. For instance, we don't need to think about how to install Posners. Not that it's too complicated, but it was hard to do on Linux. It wasn't hard on Linux, but if we have a Windows thing, there might be some sophistication. For instance, if you decided you need to raise Kafka not in one instance and to install it in a cluster would be quite a challenge. You have to read all the fine print to do that. So with Docker, it's much easier. You write Docker Kafka cluster, and then you move to the peer. Maybe there's a second, to the first or the second link. You copy it. Voila, your Kafka works. It simplifies first immersion in the new technology, and then the speed of operation with these new technologies was also shortened because of the simple reason that your database between tests can change, and in principle it would make sense for you to control them. But with Docker, you just recreate a new one. Voila, it works. The first thing that I wanted to tell you about Docker Compose, this is like an orchestrator with a no-frills orchestrator. We do Docker for each service. Then we need to combine it in network and attach volume. There are many commands from Bash, and it's very easy to make mistake. Docker Compose is a declarative description. Here you can see the list of what we were describing in the regular Docker. Everything is elegant and easy to work. Who has experience of working with Docker Composer? In that case, I would advise you looking at this because everything is so straightforward. Read a small getting starting and start using it. It will save you a lot of nerves, a lot of resources, and your life will become much simpler and happier after that. What are we going to look at? Most of my presentation will contain some of the live coding snippets for you to see how it is happening. Not just that it works on my machine, but it's working right here and now when I'm standing in front of you. And I'm a bit also worried about this. We have a total of 4 services. At the moment, it's a bit different example vis-a-vis what I showed in the morning, but the idea is about the same. Not that I have a huge fantasy about what testing services to imagine. We have Tor service, we have ordered service, we have warehouse service, and guarantee service. Everything is written on Kotlin. We have different methods. Getting a list of orders, getting information about a specific order, buying, return of the order, and request for guarantee. The thing is that each of these requests is going through all 4 services, is communicated through them, and as a result, the systems are interlinked with each other. If you find it interesting, you can check it out in repository. Everything I told you about can be found here. At the end, you will see some links. At the end, you'll see how you can reproduce what I'm talking about here. Okay, give me a wave, whether you've ever done a checkout. Okay, moving on. How are we going to build it? In fact, like this. We have end projects, and we can use this technology which is called Git modules. These are submodules. We add to our Git repository some additional submodules which appear there as separate projects. The main Git repository continues to operate there. They come additionally there, and whenever you update something, the chief feature of this, when everything is configured for development. Say a developer comes in and says that I rolled out a feature on Sierra 100 task. You change a branch here, and do git submodule update, and you get this branch in your project. In other words, you have a project which looks at n other repositories, and by using the declarative file, you can show which branches you want to work with now. Let's see how it works live. Now I'm going to continue speaking to the microphone. Okay. Okay. Let's move to the presentation mode. We have our Git modules, which are physically located in our project. And here you can see the connection of 3 submodules. This thing is quite tricky if you manually edit it. So you're advised not to edit it manually. There are 3 projects, but as I told you in the original background story, we have 4 of them. So we need to add one of them here. We have warehouse service. We add warranty service here. Can you see? Okay, let me increase the size. Okay, let's write git submodule at. In fact, we're just saying here that git submodule, we add master branch, we name it git submodule warranty services, and we put it into the git submodule warranty service folder. Enter. It says force here because it had been added before and removed later. Okay, we move into the project. We see that we have a new service here. You can see that in the modules folder we have a new service. It wasn't there before. See, it's a new stuff here. And here, see, it's not the source files here. In the main project we have the source files, but here in Git, here, we see only the reference to sh commit, not the physically I add Control-C, Control-V, but rather the reference to that, or link to that. So we get this ring of power that attracts all other rings. Okay, we have added it here, and we go back to our original presentation. Now we have to launch all of this. What do? We have to put it all together. Then, as long as we are working on Java, we have to do it there as well. Then we package it all together in Docker. Then we'll launch it and we get profit. Okay, let's do it one at a time. We first have to put it all together. To put it all together, everything is quite straightforward because we use the same one language. We take or go through all the folders in the modules directory. We can throw out this line from here, and we just launch clean build and show the directory where we are at the moment. Let's see how it works in code. I open up build all, and we add here well, in fact, everything is ready. The script is about the same. We just add in some launch time here. We go to the console and launch it. As we had seen before, in code, not the best option here. We go through all the directories here. And from each one of them, and one at a time, of course, sequentially. And the build time is the sum of each build, so it's not the best option. So that's why next to it, we have the builder called build parallel. You can launch this flows in the background it takes the idea of the process and then it goes in the background and verifies that everything is built successfully. So this thing can save you about 5 times the time. So it'll take us about 4 times to build it together because the project is not that big. We just have put together an order service, a store service, warehouse service. These are simple story tests from test containers that in principle we look that it is launchable in the first place. In small number of projects, this parallel launch is not going to save you a lot of time, but if we have, say, 10 modules, then you will save a lot of time there. Like it would be 4 minutes versus, or 3 minutes versus 10 minutes. Okay, back to the original sequence and back to our presentation. Perfect. Okay, we put it together. The first action is done. Next thing, we have to fold it in the Docker. It's quite straightforward. We just take it and in Docker Compose, we write an additional service. 2 things to note here. First, Docker Compose knows how to build. So it's existing not only for the launch of existing images, but it can build them as well. So build model store service is written here. It understands that below this, in the same folder, it can find Docker files. That's how they build them. But the second thing here, the second image here, is looking at the storage. So it lives in Docker Hub, which allows us not to reassemble or rebuild it again and again, but instead in Docker Compose you write that this project is retrieved and this one is built. Now, yes. Okay. The internet is down, unfortunately. Let's look at our Docker Compose. Nothing is extraordinary here. We have progress, order service, and warehouse service here. Everything is straightforward. Title of the container, published portals, published ports, and the environment. This is the Spring application with some small specificity to it. So far we have 3 services here. Let's add the 4th one. Warranty service has just been added. Let's add it here as well. Better still, let's make a Docker pull for the existing one. It will then pull it in. Maybe you cannot see the fine print here, but it pulls in the order service here, store service, warehouse service, and orders. So we don't have warranty here. It hasn't been collecting it. It has just pulled them from remote repository. Well, as far as warranty service goes, everything is the same. We just have port 8180. So I'm not going to recode everything, if you don't mind. I have done Control-C, Control-V here, but these are not the most important parts anyway. Everything is built in Docker, but we still don't have warranty service. Let's do it manually now. And here, as you can see, I have Docker Compose pull, and it pulled everything that we had. If I say Docker Compose build, warranty service, then it's going to collect only this. It will do it quite quickly because everything has been cached. If we make Docker paste, then they're going to show the old build time when I was preparing this presentation, but the chief idea here is that the testers don't need to rebuild it all. My Docker Compose can enumerate the services that we want to launch. As a result, even if we have 10, 15 services, then when enumerating, say, 5 services, we can raise some part of the infrastructure and check it there, which will first save you a lot of resources and time. but your PC must be quite powerful. In the previous report, I was standing with a small Mac. It had 16 gigabytes, and this one is 32 gigabytes to make it faster. It's much quicker for the demo. Back to the presentation. Perfect. Okay, everything has been folded into Docker. Now we have to launch all of it. The launch in Docker, if we take the standard one, then it's Docker run. But as long as we have Docker compose, it's going to be called Docker compose up. We will launch it and check its compatibility and how it works. Now I'm going to launch it in real time. First, we have Postgres, so it starts first, and then we're going to see our services here. All the logs are quite long here, numerous. We can do it in the background, of course. We'll see and how it pulls logs for specific services. We'll wait and see when it is launched. First one is launched, second is launched, third is launched. Looks like everything has been launched. Perfect. To demonstrate that all of it is workable, there are also some scripts. I'm going to launch them through Newman utility. There are a total of 5 requests. First request. First inquiry, health check, it's done. Then procurement or purchase order. Well, it's going too fast because the computer is too powerful. Then buy verification, then order verification for specific customer, then all orders. Then we get inquiry on warranties. Over this, you can see some tests on Postman. When I wrote tests on Postman, I realized that it's quite a useful instrument, but I've wasted a lot of my mental health on this to develop this scenarios. It's not the most user-friendly option, or maybe I'm not good at using it. Okay, we have launched it, and we have seen that it all works. And eventually we have a profit. Now I'm going to demonstrate to you in about 10-15 minutes that we can automate our work quite easily, and you can launch it at your local computer. Let's speak about some of the nuances. First is the sequence of launch of the services. Here you can see two links to the official documentation and different options. When I was showing to you Docker Compose, here there was a special line starting with depends on. In Docker Compose, there are restrictions. There are no limits on memory and there are no health checks. As a result, depends on does mean that we'll have to wait until Posners are launched. We just show them the sequence of launch and sequence of stopping. If, as a result, we have something more complicated like Kafka is written in Java, so it takes a while for it to be launched. If we launch Kafka in clusters, so it takes a hell of a lot of time. And if some of our projects are linked to Kafka during the start, they're going to crash for sure. You can fix it by the command called restart on failure, but this solution will show you a lot of exceptions in code, which is not good for anyone. As a result, we need something more sophisticated, which will help us to set up the sequence of launch.
This is mainly a problem for Java. If we launch the project but cannot connect to someone, then in Python, the connect to database to Kafka happens during the first request. But nevertheless, we are going to talk about expectations. You know that your product doesn't launch during deploy phase, not when the first user sends a request. So how do we do this? We do this with an additional utility, wait a such. It's a binary utility starting from 2.10 version. In the entry point, besides launching an application, when starting, we need to add wait host and wait timeout. So wait is such is waiting for the availability of hosts for 200 milliseconds. If they are not available, it crashes. If it's available, it launches. Let's have a look how it works in reality. Let's take store service will wait for the order service, warehouse service, and warranty service. And since our Docker file is a little bit different, there are two Dockers. Docker for demonstration of this waiting by the utility. So we'll run it and we'll see how it looks. We stop our existing containers, clean them up, Docker down, and launch our Docker Compose. Wait, and start it. So the first thing that we can see here is the store service. It shows us that it awaits for the availability of the following services. Our services start up and order server not yet available. At this moment our order service launches, host is available, host warehouse available, host warranty available, and the store service is launching. On the one hand, it's a kind of temporary solution. On the other hand, it's quite an elegant solution for the launch. And otherwise, it would be difficult later on to work on the incidents, because the system is not available or something else might happen. Okay. If you want to try it, there's Docker Compose Basic, Docker Compose Waste, Docker Compose Remote. I would like also to tell you about debugging inside the container. We'll have a look at Java. In Python it's a little bit different, but generally the same. We launch an agent lib, additional library that opens the debugging port. Besides the main port, we expose the 5005 port, and that's it, actually. Let's have a look how it works. We remove all the extra stuff and put Docker Compose. We'll launch it in the background. Console is available. All containers have been launched. In order to look at the login, we can write Docker Compose logs -f store service order service. So we do see it. It goes one after another, but later on it will be mixed up. To have a look at the debug, we will launch it through the script with 5-second interval. We'll launch it, run, and we can see our logs all mixed up. So our debug is working on the order service. It's launched based on the order service. I will leave the presentation mode and just zoom in for you to see. We create remote debug here, localhost, and 5005 port. Then we go to the, one more. Besides that, we mentioned the class pass. It's order service in our case, and all the debugging information that we get to this 505 port is related to the source files in the order service. We open web and breakpoint into the method of information retrieval. Here is the breakpoint. And we got stuck in console. Okay, the method is done. Again. 48 milliseconds, this is the time for the method execution. Okay, let's remove debug and stop it. So we do see that when we receive this information about the order, there will be quite high time, 18 milliseconds. So we do see that there is a possibility for debugging. Let's summarize. First of all, it's not the silver bullet, it's a kind of alternative to the poor guys, those who don't have possibility to do so because you need DevOps, infrastructure, and money for the servers. But you want to test, of course, so that after the developers, this application doesn't go straight to the production. Of course, in the production, it's the most reliable way of testing. But when users push the first button and then the whole app crashes, they get very much upset, you know. That's why we need to do it. I bought Lego for my child that costed 30,000 rubles. I clicked the button pay and it all crashed. There was a mistake or error message, but the money was gone. Everything ended up fine, but still it was a very unpleasant moment. So this solution is a kind of possibility for the local testing when you don't have any possibility for the fully fledged test. Docker Compose is a convenient tool. There are certain complexities, but if container is launched, then the Docker considers this as a launched container. Container might get launched with exceptions, but the Docker says it as okay. Developers cannot say anymore, well, I can't do this to test. They can do it easily now. I showed you that it takes 10-15 minutes to test. It simplifies your communication with the developers. And another killer feature, you can debug inside the container. the developer might sit with you, connect to this, and you can have a look together. Because sometimes the error is not simple. It's quite unclear what is happening. Link to the repository, my contacts, my GitHub data. You might have a look at my projects. Thank you for your attention. Questions? Any questions? Thank you for your presentation. I have a question about why we use Cosmo for the IP tests, not what is written in Java. Well, I tried this Postman with the students. I have fifth grade students who are not obliged to use Java. When I gave them Java tests, people didn't understand what was written there. But in general, it was a pain in the ass. And I thought that we need to have a more universal tool. And I realized that you can import API collection into the Postman. You import API into collection. In the collection, you prepare a number of tests. It was rather painful, but it works. You know, it works. Without any link to programming language. And tests are rather good for the students because they understand what I want to get from them. Whatever I did before by preparing a task for them, they didn't understand. But in this case, it's quite easy. If you did it right, then test works. That's a good indicator for the students. I have 2 flyers for t-shirts. Who wants a t-shirt? Can we implement Docker 3 iOS? You mean launching tests on Docker for mobile application? Well, I didn't think about this because we're launching backend here. It's a backend type testing inside the container because Mac has an image in Docker now. Well, if we take tests, it's not Ubuntu, it's OpenGDK, but limited one. The idea is that we're lifting services, tests are separate. I took all my apps and from the local point I started testing, not inside the container. Oh, that's clear. Thank you. Any more questions? 1, 2, 3. Thank you.